neural development. And you guys ready? The first slide, we're looking at neural tube formation, and this is day 21 post-conception. Okay. What you're looking at here are four different pictures. This is going to be day 21, and then this is going to be progressing from day 21 to this picture and then to this picture. So what you're looking at here is we're going to talk about the development of the nervous system, or development of the embryo, specifically the nervous system in the embryo. Okay, starting at day 21 post-conception. So looking at this picture, we have a few things to label. You need to know that this is going to be the first thing that we look at over here. This is the first section, in the top left. There are three different sections. There's this top section of the embryo. Okay, the top section of the embryo is known as the ectoderm. 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 The ectoderm is going to be the future CNS, PNS, and skin of the baby. And right underneath the ectoderm, here we have this middle section. The middle section is known as the mesoderm. M-E-S-O-D-E-R-M. It's your mesoderm layer. And the mesoderm is going to be the future muscles and skeleton of the baby. Right on cue. Okay. Down here we have this lowermost layer of the embryo. This lowermost layer of the embryo is known as the endoderm. E-N-D-O-D-E-R-M. The endoderm is the future GI system for the baby. Okay, so starting out day 21, three different embryonic layers exist. The topmost layer is your ectoderm. It's the future CNS, PNS, so the future nervous system plus the skin of the baby. Mesoderm, middle section, future muscles and bones or skeleton. Middle layer, or bottom layer, is endoderm, future GI system. Essentially what's going to happen as the embryo develops, these three structures, or these three layers, are going to fold over on themselves and create like a tube. The outer layer is the skin and CNS and PNS nervous system, and then the muscles are inside, and then in the very middle is going to be your GI system. Okay, so it's just going to fold over on itself eventually. Other important things to know about this embryonic structure is this right here. Okay. That right there is known as the prechordal plate. C-H-O-R-D-A-L, plate. Okay. And at day 21, you already know the top from the bottom of the baby, because the prechordal plate is going to be the future mouth of the baby. Here in the mesodermal layer, right here I just have a section through the three layers, but this is specifically in the mesodermal layer, what I'm coloring green here, And this structure is visible in this section, but it also goes all the way up through, right in here. It's all the way through the mesodermal layer, all the way up to the precordial plate area. And that is known as a notochord, the notochord. Notochord is N-O-T-O.
Can't see it.
Thank you, C-H-O-R-D. Okay, and that's the first step at day 21. Okay, and moving on, as the embryo grows, we're going to go to this next structure, and we'll label this number 2. Great question. We're going to see that in a minute, but I'll put in some stuff here that'll give you some information. The notochord is going to release growth factors. And I'll show that here in just one second. But overall, you should know that the notochord is responsible for releasing growth factors. Any other questions about this? Okay, again, so the uppermost layer is going to be my ectoderm. Alright, and then I'm going to have my mesoderm in the middle. And then I'm going to have my endoderm on the bottom. Okay, I still have my precordial plate here, future mouth of the baby. And I still have my notochord. So everything looks about the same, except now we see that we have a raised structure, and this raised structure here is formed because as the notochord residing in the mesoderm releases growth factors, those growth factors come up and cause a thickening in the ectoderm, specifically directly over top of that notochord. Okay, so here you have the notochord releasing growth factors that cause a thickening in the ectoderm above the notochord. Okay, and this thickening has a special name. It's called a neural plate. So this orange thickening is known as your neural plate. Okay. And a neural plate is nothing more than just a thickening of the ectodermal area that resides over top of the notochord. So the notochord was releasing those growth factors, which causes that thickening to happen. Okay, it looks like a flat plate. Questions? Sure. The neural plate, which is this orange structure right here, is nothing more than a thickening of this ectodermal layer that's directly over top of the notochord. So the notochord releases growth factors that go up and causes the growth of a special area in the ectoderm. This is known as the neural plate. Help? Any other questions? All right, great. So moving on down, we're going to the next structure here. There's the next embryonic structure is going to be this one. I'll label this one number 3. Okay. Number 3, we still have our precordial plate, which is the mouth of the baby. We still have your ectoderm, mesoderm, and endoderm. We still have our notochord, which is in that mesoderm. what's happened here. Yes?
Is the first one day 21, and then what is the next one?
This is a progression from day 21 to about day 28.
So just anywhere in between there, just how they progress, it doesn't have like a certain day?
No, there's no day that you need to be aware of. So the first week after day 21. So essentially 21, within 1 week, this is what happens. Any other questions? All right, now looking at this third structure down here, what's happened is this neural plate has changed a little bit. And what I tried to represent in 3 dimensions the best I could, remember the neural plate's directly over top of the notor cord, and this is now, this neural plate folds in on itself. So in other words, if this piece of paper were the neural plate to start with, what I'm trying to represent is that I'm forming a groove. See how it kind of curves in on itself? And I get this groove here. The neural plate becomes more of a groove, like just a channel. Okay? And I'm choosing the word groove to represent this fold because this is now turned into something known as the neural groove. Okay, so the neural plate folds in on itself, folds down, and that becomes the neural groove. Okay, so nothing fancy, so it's just this neural plate kind of folded in, and then you get this neural groove. And then continuing forward, you have the fourth embryonic image that we're looking at here. Okay, again, we have our prechordal plate up top. We got our notochord down here on the bottom. Still 3 different layers, ectoderm, mesoderm, and endoderm. Only now, this neural groove here in figure 3, it was like this. Okay? By figure 4, that groove has formed a tube. Okay, so if the paper is the plate, and then this is the groove, that groove kind of comes all the way around and creates a tube. Okay, and that's what this is called. This is your neural tube. Nothing more than the folding over of the neural groove. Okay. And this neural tube structure right here, this is the future CNS of the baby. So the central nervous system. So that's the beginning of the brain and spinal cord together. It comes from the neural tube. And that formation is complete by about day 28. Any questions? Yeah, Chase?
So the neural tube is just a complete folding in of the neural groove?
So it completely folds in and makes a tube. Any other questions? Okay, a couple other things we need to label here. Thinking about these cells here, as the neural tube comes in and folds off on itself, some of the cells from the top, as it comes together, kind of fall off and go to the side here. And these are known as neural crest cells. So all these cells lining the outside are just your neural crest cells. There you go, thank you. Okay, and your neural crest cells are going to be the future peripheral nervous system, or the start of the peripheral nervous system for the baby. Questions? Got it? Oh, it's pretty straightforward. Now, in thinking about the formation of the brain and spinal cord. What's going to happen is you're going to have a completely enclosed tube. And so here you have, right now, at about day 27 or so, you have an opening here in the bottom, okay? And you also have an opening here in the top, okay? And what I mean by that, if I'm looking at this paper has an opening here in the top, isn't closed yet, and also has an opening here in the bottom, right? So right here, that's what I'm indicating here. It's just the openings in the top and bottom of this neural tube. Okay. Down here on the bottom, this opening on the bottom, opposite the precordial plate, is going to be your posterior neuropore. Neuropore. Okay, and that posterior neuropore is nothing more than the hole in the bottom of the neural tube that hasn't closed up yet. Yes? Posterior neuropore. 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 Because, here we are, we need that hole to close. There's an important presentation. Design, go ahead.
I was just going to ask you, so when it is open, what causes that?
This is a neural tube defect. If the posterior neural pore does not close, then that's a neural tube defect. Do you know the name of it? And the posterior neural pore doesn't close, the baby develops something known as spina bifida. And you'll hear more about spina bifida next year in peds. Okay, spina bifida. Spina bifida is nothing more than the absence of closure of the posterior neuropore. Different levels of spina bifida, you'll learn about it next year. You just need to know when the posterior neuropore doesn't close, the baby develops spina bifida. Big problem. Potentially a big problem. Do you know how to prevent spina bifida from happening? Folic acid, yes. Supplement with folic acid, or eat your dark leafy green vegetables, or both. Right? That's really important. So it's been found that if a mother doesn't have enough folic acid, you get this terrible posterior neuropore defect known as spina bifida in the baby. And it can be very severe. Okay, so if you supplement spina with folic acid, you don't have that problem. There's also another problem that can happen if this top hole doesn't close. Okay, this is the posterior neuropore down here. This one's the anterior neuropore at the top. So at the anterior neuropore, and again, this is preventable with folic acid. If the anterior neuropore doesn't close up, it results in a defect that's not compatible with life. Okay, it's known as anencephaly. A-N-E-N-A-C-E-P-H-A-L-Y. Anencephaly. Yes. A-N-E-N-A-C-E-P-H-A-L-Y. Anencephaly. Anencephaly is a failure of the anterior neuropore to close, and the baby is born without a cortical region. So essentially you have your brainstem, and it's covered with meninges, and there's no skull. Okay? And it's not compatible with life. Questions about that? Yes, Johnny? I don't know what the prevalence is, to tell you the truth, but it's fully preventable. It is very preventable. I don't know what the do you know what the prevalence of spina bifida?
I mean, it's more rare even than spina bifida, but it's not very.
Yeah, I've known somebody. I've known a couple that had a baby born with anencephaly. Not a good thing, especially since it's preventable. Any other questions about that?
Wait, how do you especially like
Did you say that?
Folic acid, yeah.
Oh, the folic acid.
Yeah, the folic acid promotes the closure of both the anterior and posterior neural pore.
So do you obviously you get blood work while you're pregnant, so they
yeah.
tell you probably if you're going to be at risk for that.
Yes, you know if you're at risk, and then usually they find anencephaly you can see on an ultrasound at like 5 months. So, okay, other questions? Okay, let's move on. This is by about day 27-ish, and now we're going to move on to brain formation, and brain formation happens day 28 post-conception. This doesn't look straight. There we go. Okay. So what you see here and day 28 is the first image here is going to be the fully closed neural tube. Okay. So this is, so here's the anterior portion. Okay, here's the posterior portion. Okay, and then this is day 28. This is your neural tube. So when thinking about brain formation, I also like to think that as the neural tube presented, remember the neural tube is literally a tube with now the top and bottom are closed off. So there's like this nice hollow space in the tube, right? There's a hole there. Okay, that's going to be important for thinking about what happens going forward. Okay, so here's your neural tube. This neural tube is hollow. First thing we're going to talk about going from this neural tube at day 28, progressing forward as the embryo develops, we're going to talk about something known as primary, abbreviated primary brain vesicles. V-E-S-C-I-C-L-E-S, vesicles. Okay, so what's happening here as the neural tube develops, you're going to start with the development of 3 different primary brain vesicles. Okay, these are nothing more than just swelling. So that tube at the very top, at the anterior portion of the tube, is going to start to swell in 3 different regions, or start to grow specifically in 3 different regions. Okay? The first anterior primary brain vesicle is going to be this one up here, and this is known as the prosen, P-R-O-S-E-N-C-E-P-H-A-L-O-N, prosencephalon.
Can you spell that again?
P-R-O-S-E-N-C-E-P-H-A-L-O-N. That's your prosencephalon. And your prosencephalon is one of your primary brain vesicles, and it represents the very top growth of that neural tube. Okay. The next brain vesicle down is known as your mesen, M-E-S-E-N, cephalon, C-E-P-H-A-L-O-N. So the next growth underneath the prosencephalon, another primary brain vesicle, is known as your mesencephalon, M-E-S. Yes?
Do either of these form something like how the CNS was starting to form? Is this starting to form something else?
This eventually will be the brain. We're going to go this way to get to this structure. This one actually ends up being the midbrain. So what's good? Follow me along. We'll get there. One step at a time. You should know that from the neural tube, the first thing you do is you form your primary brain vesicles. Okay? You have 3 primary brain vesicles. The uppermost is the prosencephalon, the middle one is the mesencephalon, and the lowermost brain vesicle, primary brain vesicle, is known as your rhombencephalon. R-H-O-M-B-E-N. B-E-N-C-E-P-H-A-L-O-N. Rhombencephalon. So you have your prosencephalon is here. Okay, that's the topmost swelling. Your mesencephalon is the middle swelling of your primary brain vesicle, middle growth. And then your lowermost growth is known as your rhombencephalon. Okay, does that help? Yes? Rhombencephalon, R-H-O-M-B-E-N-C-E-P-H-A-L-O-N. Any other questions? Yes?
Is there specific functions for you at this stage, or is there
It's going to come by the time we get to here that you should be familiar with the functions as we go, and we can talk about them as we go. Okay? So what's going to happen is that prosencephalon, the topmost portion here as a primary brain vesicle, is going to start to rapidly divide. Okay? In this next image, we're going to talk about your secondary brain vesicles. And as you can see, we're making our way over to what we consider the CNS proper, or what we've been drawing so far this semester. And your prosencephalon, okay, your prosencephalon, which is here, rapidly divides and forms two different things. Okay, the first thing it's going to start to form is going to rapidly divide and form this topmost region here. Okay, so your prosencephalon becomes what's known as your telencephalon, T-E-L-E-N-C-E-P-H-A-L-O-N. Your telencephalon is the topmost portion, and that's going to develop into your cortical region, or the future lobes of the brain, future cortical lobes. Right, so all the things we've been talking about, your anterior lobe, temporal lobe, parietal, occipital, that will come from your telencephalon. Okay. Your prosencephalon is also going to create another area. It's going to be this area right here. Okay, that area that I've represented in kind of the maroon color, that's known as your diencephalon, D-I-E-N-C-E-P-H-A-L-O-N. That's your diencephalon. Okay, that's just another area of growth that's derived from the prosencephalon. Okay, the telencephalon rapidly divides. The diencephalon is an area of cell division underneath the telencephalon that's known as the diencephalon. Both of these originate from the prosencephalon. Understand? And then the diencephalon is going to be the future thalamus and hypothalamus of the baby. Okay, so the thalamus and hypothalamus comes from prosencephalon. There's one more thing I'd like you to consider. If we started out with a hollow tube here in the neural tube, and we make our way over to the telencephalon, it's hollow inside. What do you think those hollow things are known as in the cortical region?
Ventricles.
Ventricles, yeah, those are going to house your lateral ventricles, specifically in the telencephalon, right? Okay, so thinking about the diencephalon, if the diencephalon is going to become the thalamus and the hypothalamus, what's that hollow space become in the area of the diencephalon? Which ventricle? The third, right. So the third ventricle exists right between the thalami, remember? Okay, kind of cool. Yes?
Which ventricles for the telencephalon again?
Telencephalon is going to be your lateral ventricles, because those are the ventricles that exist in your cortical regions. Okay? Any other questions about that? And your diencephalon is going to be your third ventricle, because it sits right between your thalami. Okay? And then moving on down, this mesencephalon here is still your mesencephalon here, so it just is the same. Okay, this is still your mesencephalon. Okay, this is your mesencephalon is going to be your future midbrain. What's the ventricular portion in the midbrain called? Cerebral aqueduct. Okay, so that hollow space is cerebral aqueduct is going to be in your mesencephalon, and your rhombencephalon is going to be one of those that divides rapidly and forms two different regions. Okay, so your rhombencephalon is going to form this here, which is your future cerebellum, correct? As well as your pons. So the cerebellum and pons actually develop together. Okay? The topmost portion with the rhombencephalon, so the rhombencephalon rapidly divides and becomes an area of secondary brain vesicles that's known as the metencephalon. So that's M-E-T-E-N. Cephalon. Okay, your metencephalon is composed of your future pons and cerebellum. Okay, and moving on down, the rhombencephalon also forms another region here. This is going to be your future medulla. Okay, this area of secondary brain vesicles is known as the myelencephalon. M-Y-E-L-I-N-C-E-P-H-A-L-O-N. Myelencephalon. Myelencephalon is going to be your future medulla. Myelin, L-E-N. Okay, and then you can see when you get to the level of the brain and spinal cord that we know, okay, here's derived from your myelencephalon is your medulla. Derived from your metencephalon is going to be your pons and your cerebellum. And then derived from your mesencephalon still is your midbrain. And what happens here with the telencephalon and the diencephalon is the telencephalon, as it rapidly divides, is going to fold over onto the diencephalon, and that's why your thalmi come in the middle. So what you see is this diencephalon now exists exclusively inside the area of that very large telencephalon. The pink. Pink, or I have it maroon. Yeah, so the diencephalon is going to be in the middle. Those are your thalamus, thalmi, and hypothalamus. Yep. Yes.
And what does the mesencephalon hold or house in the second brain vegetable?
What does it house? So it's still the mesencephalon. So the primary vesicle mesencephalon still stays as mesencephalon. It doesn't change. It's the midbrain. It will become the future midbrain in the brain. The ventricle is going to be your cerebral aqueduct running inside of it. Okay? And then moving on down in the pons, you've got your fourth ventricle, right? And then moving on down, what's the name of that hollow space inside the spinal cord? Central canal, right? It's still there. Questions? Yes, Mackenzie.
The telecephalon, when you said it folds onto the whatever.
Diencephalon?
Yeah. Is that when it becomes like the ventricle area?
No, the ventricles are inside, so that this is all, this space, there's space, like here, this was all hollow. Well, this is hollow in here. Those are the ventricles.
So they're still hollow.
They're still hollow.
When it folds over, is that when it makes the thalamus and hypothalamus?
So the thalamus, as the brain develops, there are secondary brain vesicles known as the diencephalon that contain the thalamus, or will be the future thalamus and hypothalamus. So, bless you. When you start out, the telencephalons on top starts rapidly dividing, and then there's another area that comes from your prosencephalon that isn't dividing quite as fast. That's your future thalamus and hypothalamus. So what happens is, as the telencephalon grows, it sort of like engulfs the diencephalon or the thalamus, so it ends up inside. I'm trying to think about how to. Does that make sense to everybody? Yeah, Alicia?
Would the third, the final picture be like the tertiary brain vesicle, or is it just?
That's the brain. Yeah, that's the CNS. Yeah, so you've got your spinal cord. So those are all the pictures, very similar to the pictures we've been drawing. Yes, Ben?
So when did so how it's labeled anterior and posterior, when does that become like superior and inferior once it's fully developed?
Once it's, so, so you should know that there's a change, so from the midbrain. Once this full structure is formed, at the level of the midbrain is when things change. Right? So that's going to be, and this is, the front would be over here and the back would be back there. So this is going to be rostral, okay, and that's going to be caudal because that's going to be the back of the brain, okay. But then in the midbrain, that's the inflection point. So around the area of the midbrain is when things change. So that after the midbrain, then the topmost portion is going to be rostral, and then the bottommost portion is going to be caudal. Another way to say it is, when you get to the area of the midbrain, you start thinking about the spinal cord, and the spinal cord has rostral top and caudal bottom. Where at the level of the brain, the front is the rostral and the back is the caudal. And if you think about an animal walking on all fours, as the brain, as you move down past the midbrain, that animal starts to sit up on two legs, and that's when it changes. Does that help? Is that your question? Okay, I wasn't sure if that was it or not. Mikey?
Well, yeah, I sort of see it. So right now
Okay.
it's all the same terminology, but then as it develops, once it develops, then it makes that change.
Mm-hmm. Yeah, there's like an inflection point at the level of the midbrain that causes that change. Yes? How you? No, sure.
On the second order, where it's like the future pons and the future cerebellum, all of that is involved in that same
Future pons and future cerebellum. Yes, the pons and the future pons and the future cerebellum are together known as the metencephalon. Okay, and so sometimes it might be kind of hard to remember all these names, and one thing I like to do is put things in alphabetical order, and it's conveniently done for me because the midbrain is mes, S comes first, and then the next is met, ST comes after met, after S, right? And then MY, so it's STY, so mesencephalon, metencephalon, myelencephalon. So that helps me remember the order. Any other questions? Yes, Ashley. I don't know. Do you know the last day, Dr. Blair?
I know this goes to at least like day 100. The last part's at least day 100. So it's those vesicles are over a number of weeks.
Yeah.
But day 28 is early on.
Yeah, day 20. I mean, I think the most important thing to know is that at day 28, most people don't even know they're pregnant, right? So that's the important part. I mean, if you're planning on having a baby, you need to start getting healthy way before you even start trying to have that baby. Okay, because day 28, you're already starting to form your nervous system. That's kind of an important part of the baby. Okay? Any other questions? Okay, one more slide. One more. Okay. This is spinal cord formation. And again, your spinal cord is going to start to form at day 28, just like your brain. So when all this stuff is happening up above at the level of the brain, there's also some stuff happening down below at the level of the spinal cord. Okay. What we have here is this is just a cross section through your neural tube. All I've done is just taken the neural tube and I've just sliced it right through the middle. When I told you that neural tube will become the future CNS, and now we're going to look at the formation of the spinal cord at day 28. Same thing happening when the brain's forming. I also told you that there was going to be something that's the future PNS of the baby. Does anybody remembers what those cells would be called? Yeah, good. Those are your neural crest cells. Okay, when I look at this picture, I see this nice hole. This is going to be the hole that exists, that hollow space filled with CSF in the spinal cord. This is going to be my central canal. Okay, and surrounding my central canal in this cross section of the spinal cord, these are neuronal cell bodies. Okay, all these dark circles here are neuronal cell bodies. And this layer of neuronal cell bodies has a special name. It's called the mantle. M-A-N-T-L-E layer. Okay. Mantle layer is nothing more than a collection of neuronal cell bodies that currently at day 28 exists around the central canal. Okay, and that mantle layer is going to be the future gray matter of the spinal cord. Okay, in addition to the gray matter of the spinal cord, we also have white matter. That white matter is going to be all around here. Okay, where the neuronal cell bodies, or the gray matter of the spinal cord, is known as the mantle layer. This white matter is known as the marginal layer. And that's going to be the future white matter. Of the spinal cord. Okay, so that's where we're starting at day 28. Any questions about that labeling? Hopefully it's pretty straightforward. We're going to start out with the central canal here. So I'll put the central canal here, and this is going to be my central canal in the center of the spinal cord. What happens is that marginal layer starts to divide rapidly and forms up top kind of a butterfly-shaped wing here. This butterfly-shaped wing is filled with those neuronal cell bodies that are rapidly dividing from that mantle layer. Okay, and it's going to be bilateral. So we have this is nothing more than the rapid dividing of that mantle layer, which I said would be the future gray matter of the spinal cord. And these two areas are known as the alar, A-L-A-R, also known as the association plate. So you might see the alar plate or the association plate. Okay, both mean the same thing, and that's the future dorsal gray horn. Bless you. And same thing. Yes, Ruthie.
So, the mantle layer rapidly divides, and those are
Neuronal cell bodies.
rapidly dividing.
Yep.
And so the alar plate, is that like a round cell body?
So think about it, so when I draw a cross-section of the spinal cord, think about it becoming the dorsal gray horn. That dorsal gray horn is filled with nothing more than the neuronal cell bodies, and that's the gray matter of the spinal cord. Does that make sense? So the same thing's going to happen. So that's the dorsal gray horn, and then we also know there's going to be a ventral gray horn, right? So I'm going to draw my ventral gray horn here. Remember, this is just spinal cord development. So I'd expect my dorsal gray horn to be there. I expect my ventral gray horn to be there. And this is my future ventral gray horn. Again, this is nothing more than that mantle layer rapidly divided neuronal cell bodies. These neuronal cell bodies are going to be the future alpha motor neurons or lower motor neurons that we've talked about so much. Okay, where this is going to be my future ventral gray horn, and this is known as my basal, B-A-S-A-L, or motor plate. Okay, so you have your alar or association plate, and your ventral gray horn is going to be your basal or motor plate. And then this is going to represent the future ventral gray horn. And it's going to house the future lower motor neurons. All right, almost there. And we also we know that the spinal cord is going to be around here with the white matter from the marginal layer. That's going to be all my white matter here. But we also know that we have these neuronal cell bodies here in the PNS that are going to be part of that dorsal root ganglia we talked about so much. So these are going to be these are your dorsal root ganglia. Okay. So those neural crest cells, the neuronal cell bodies inside your dorsal root ganglia. That is it. That's all we're going to do. That's plenty. Just a little bit of time for lab. We'll probably just get the reflexes. We'll see. We'll have more time next class. Okay, questions about